Hello, everyone. My name is Chris Modrich. I'm one of the vice presidents here at Lesman. I'd like to thank you all for taking the time out of your busy schedule to join us today for the path to hassle-free bulk solids measurements. In this approximately 30-minute webinar, Becky Olliges of Ronan will cover how to uncover the obstacles inherent to bulk solids measurement. She will review environmental factors that affect measurement accuracy and how to mitigate them, and will discuss how to handle issues related to mounting locations and movable equipment. She will also introduce non-contact technology for accurate measurement. And at the end, she will answer any questions in a quick live Q&A session. Please don't hesitate to ask questions along the way via the chat function. I'll attempt to work them into the presentation where they fit. And if not, we'll save them up for the end. A little bit about our speaker. Becky Olliges has nearly 15 years of experience working with gamma nuclear gauging. Becky's currently a sales engineer at Ronan Engineering in Florence, Kentucky, and she provides measurement solutions to customers on a daily basis. So at this time, I'd like to welcome Becky as our featured speaker today. And Becky, it's all yours.
All right, thank you so much, Chris. Thanks everybody for joining. Like Chris said, the goal is to talk about bulk solids measurements, and specifically a solution that could offer you a long-term hassle-free measurement. So my goal for today is to provide you with the solution for hassle-free measurements so that you'll feel comfortable and you'll understand that you don't have to do regular maintenance and upkeep of your weight systems. How we're going to do that, I'm going to discuss some obstacles. We'll introduce the product. I'll give you an explanation of how it works. We'll talk about how the product is calibrated, offer some reasons that we call it hassle-free, and then show you some application examples. So the most common way that we hear people measure bulk solids on a conveyor or on a drag chain on a screw is by using some kind of traditional weight scale. Those scales could be items with load cells, balance beams, string gauges. All those products come in direct contact with the conveyor. They require frequent maintenance, and this maintenance is because of the exposure to vibration, buildup, large amounts of weight running across the belt or the screw. The installations of the traditional style of weight scale can require a shutdown of your belt. Some of them take the need to disassemble the belt. There are some that need very precise floor pads underneath and alignment of their idlers. So all these things compound into lost production time. And if something was to fail on the system, obviously that would be an unscheduled maintenance. That would require a repair from a specialist that you wouldn't have necessarily on site. So the solution that Ronan offers that a few of our competitors offer is a non-contact measurement system where we use a small bit of gamma energy to measure density, mass density of the product on the belt, and then we take that combined with speed to give you a tons per hour output. This system is not affected by misalignments, by changes in the belt tension, high vibration, dust and dirt. It's not affected it's not affected by product size or moisture. It's mounted externally to the conveyor. Doesn't need any kind of support. So this is a little illustration of what it will look like. The system provides a solution, and as you can see here, here's the dust and dirt that we talk about. The system is made of a source that's mounted above the process and a detector which is mounted below. Then there's a frame around the conveyor, and there's no modification required. As you can see in this photo, we went around the outside of their drag chain assembly and of their structure. Almost all of the weight applications that use a Ronan solution use a low-level source. And we'll talk about what that means in a minute. The solution provides the total weight of the process. It can be used on any kind of conveying system. For example, screws, belts, flat or idlers, drag chains. The outputs that we will provide would be weight, rate, and conveyor speed. And the goal is to be repeatable within 1% of the measurement. So I mentioned just a minute ago low level source, and we commented in our advertisement that it was using safe energy. So Ronan has a low level source that falls just below the regulatory requirement of the NRC and of each individual state. And it has no shutter on it, so there's no need for a shutter check. There's no need for the traditional leak or wipe tests. There's no need for a specially trained officer or other people on site. The users can install, can move the system, can even calibrate the system. And most exciting is no license is required for being on site. The system that we offer has a microprocessor or transmitter that takes the output of the signal. We offer a 5 microsecond update. We offer heart communication protocol as an output. We have the keypad is easy to navigate, much like the heart communicator. The box is remotely mounted from the system, so that there's no vibration, so that it's easy to get to. And we offer both carbon and stainless steel enclosure options. So you may ask yourself, how in the world does this thing work? You may be knowledgeable about how a typical load cell works or a strain gauge. The solution that we've got to offer uses a source that emits a low level of gamma energy. This energy goes through the process of the detector, through the process, and is received by the detector, which is on the opposite side of your conveyor. That detector measures the energy that's reaching it, and it takes that amount of the amount of energy reaching it is inversely proportional to the conveyor load. The amount of energy the detector receives then is converted from a light energy to a pulse, electrical pulse, that then can be transmitted to our microprocessor. The transmitter that we offer, or that our competitors offer, provides the signal outputs of weight and rate. Ours also will give you the speed of the conveyor. For those of you who like to see algebra, this is algebraically how the system works. Here's the amount of radiation times the coefficient of the mass absorption, and we take that times our loading and divide it all by the width of the conveyor. All of that is inside of the controller. You don't have any reason to worry about knowing that, but that's how generally, algebraically speaking, how it works. So I mentioned besides introducing, we'd also talk about how the system could be calibrated. And this is something that as a user of the system you can do on your own. You can also employ the expertise of one of the manufacturer's field service engineers. And you might like that the first time if you've not ever been introduced to this. So the calibration is a two-part system. The first step is to verify the speed of the conveyor, and we're going to confirm that speed either by taking an encoder to measure how fast it's moving, or if you have a drive that provides a variable frequency output, we'll take that speed signal and bring it into our controller. Then the second part after verifying speed is we want to calibrate for mass density. And what we mean by that is we're going to come up with how much radiation is being attenuated through the process. So we're going to start by zeroing or referencing an empty belt. And that's going to learn out any obstacles that are in front of it, the thickness of the belt or the paddles in a drag chain or the screw shaft. Much like a radar unit, it's going to learn out those things that are in the area, but we don't care about them for the measurement. Then we are going to run material over the conveyor, and you're going to collect it for 15 to 20 minutes. This is one way of doing it. We would verify the weight on our controller versus your catch sample. So you go weigh it on a scale, for example, and then do some fine-tuning adjustments. That process may need to run 2 or 3 times to come up with exactly an accurate output. The other way to do mass density is a static sample. And what I mean by a static sample is once you run your empty belt, then you run the conveyor with product. You stop the conveyor. Product is underneath of the device of the scale. You'll take a 3-foot section of the material, take it all out, go weigh it on a scale that you know what it is, take that weight and divide by 3 feet. Then you can input that into the system as the pounds per foot. So we've talked about calibration, we've talked about the product, we've talked about things that are different than the common obstacles for measuring bulk density. So now let's see, why in the world did we call this hassle-free? We called it hassle-free because it's not affected by change in your process, by the particle size or the shape of the product coming through, by the lows and the highs of the product on the belt, by dust, not affected by moisture. The solution has no component wear because there's no moving parts to it. It's all external from the conveyor, and it's an energy and it's a plastic receiver with a crystal inside and some electronic pieces. It can be called hassle-free because it's easy to mount, it's robust, it's an accurate system, and once you've calibrated it, there's no need to recalibrate unless you've got to replace a belt or a chain, or it's been idle for a long time. So now let's look at some installations, and I can point out some of the things about where in the world you might mount or or the environmental factors. So the first one I've got here is a sand conveyor. As you can see, the load's pretty uniform. However, this is on an angle. So a traditional scale may not like being placed on an incline. But our system, as long as it's free, you can see it's mounted in between two rollers and two idlers, So it's free from touching anything. It's perpendicular to the belt. Here's some wood chips and buildup of dust. So this doesn't affect the measurement either, because we've learned this part out, or we've calibrated based on the buildup being there. Here is an illustration of how safe the energy could be, because we've got it in all kinds of food processes. This one shows potato flakes, and this company uses our weight scales to measure anything from the whole potatoes coming into their process all the way to the products in the freezer, French fries, hash brown flakes, and they use it to control the input, their ingredient ratio. They're optimizing their efficiency. They're getting an accurate reading from our scales. Look at that one. We have good installation coal rock, or rocks in general. This is a good illustration of product not being uniform in size or shape. You can see this coal is all kinds of different shapes and sizes. This is another good illustration of non-uniform product or particle size. This is a garbage system. This is also a great illustration of mounting on an incline. And as you can see, there's not a whole lot of room for it, so we only need about 6 inches of room to put it in widthwise. Here's an installation on a screw conveyor. So as you can see here, we've got it mounted very close to the outlet. Doesn't take up a whole lot of room. And if you were putting a load cell here, it'd be very difficult to make that work without modifying your screw in some way. So this picture, we just had them open up so you could see how the process was turning inside, how the particles are not very uniform, how it's clumpy. We even have installations with rubber belts with cleating. So this is a good example of non-uniform. Here you can see there's even some area where there was not very much material. There's another food illustration, so it's safe for food process. In pet food, they're using it for blending and for optimizing that ingredient ratio. Here's some illustrations of ground products. So this is corn flour in an ethanol facility. But ground product, it is a good measurement for any kind of ground product. Wheat in a bread factory, ground mixes for a bakery. You can also see here we're measuring right through an enclosure. So that's part of the zero belt calculation where we've learned things out. So I'm going to give you a little bit of a blurb on Ronan. We do have a couple competitors who make the weight scales as well. Their names are Berthold and Omart, but this is for Ronan. Why would Ronan be a good solution for you? Primarily, it's because we have the low-level source that is unique to us. It's truly the only solution where you do not need a license. Our facility, we can customize products for any unique specification or application because we only sell the gamma energy technology. So that's our sole priority, and all of our resources are going for development of the equipment using that theory. So just to wrap up what I have presented, my goal was to provide you a hassle-free measurement solution for bulk solids, and I've done that by discussing obstacles that were inherent to standard product, by introducing a product that gives you a measurement that's free from wear and tear, by explaining the operation, giving you an idea on calibration, by offering reasons for hassle, the reasons we call it hassle-free, and then I illustrated a few applications for you. So Chris, what kind of questions are there?
Can you tell us, can you speak to the energy of the source related to everyday radiation sources?
Certainly. So our source is very low energy. Common everyday exposure that you see from the sun, from background in our environment, getting an X-ray, eating things with potassium. Our product is so low that you could stand next to it for 6 months of operation while it's operating and have less exposure than one X-ray at a dentist's office or bone. Flying 3,000 miles from Chicago to Los Angeles, you'll have more exposure to radiation.
Is there any bulk solid that won't work, that can't be measured?
I have not run into anything that cannot work. If it has enough velocity and load coming through, we can make the measurement.
How does changing moisture content of the bulk solid affect the measurement?
Our philosophy on moisture content is a pound is a pound. So if you have more moisture in the liquid, the output will be a heavier weight.
So in other words, if the stuff is moist, it will weigh more, but it consistently weighs more.
That is correct.
Okay. At this point, I'm going to unmute everybody. I don't have any more in the chat. If you want to speak up and ask a question, now is your opportunity. And I just wanted to throw in a quick experience we had at Lesman. At one of the big steel mills south of Lake Michigan, we put one of these devices in their sintering plant, at which they were having a lot of problems with traditional load cell based belt scales because of the grit in the dirt and just the environment. They put in one of our systems, put it through its trial run, and our very bright sales engineer was there to witness it, and they came up at 2% off, 2% light. And the guy says, well, you said it'd be 1%, it's 2%. And they said, let's walk over and see what happened. And it turned out that they ran the batch into a big bucket, which they dumped into a truck and weighed on a large truck scale. There was quite a bit of residue in the bucket. When they scraped the bucket out and added that to the truck on the scale, they were less than 1%. So everybody was happy. So that was an interesting little experience there. All right,
And
Becky.
that is the fine tuning at the beginning is typically where people see just a little bit of error to start with. But once it's fine tuned, our goal is for it to run 15, 20 years without any issues.
Perfect. Okay. We don't have any verbal questions. We don't have any more chat questions. So let's go ahead and close this up. Becky, thank you very much for your presentation, and thanks again for your time and sharing your knowledge during this exclusive session for our customers. Please note that all attendees will receive certification of attendance from this webinar via email shortly. If anybody has any additional questions and you'd like to contact Lesman, you can get us at 800-9-LESMAN on the phone, or you can hit me up, Chris Modrich. I'm at chrism@lesman.com. If you'd like to know more about our technologies that we supply, we have lots of webinars posted on both our website, lesman.com, and our YouTube channel, Lesman Instrument Company. If there are any subject topics that you'd like us to cover in future webinars, please send me an email, again, chrism@lesman.com. We have access to lots of products and lots of product specialists, process specialists, and we're always looking for worthy topics. So, Becky, thank you. Everybody who joined us, thank you. We appreciate your time today. Have a great day.
Thanks, Chris. All right.